Okay, so we're doing 7.2, day one, all right, of solving exponential equations and inequalities. All right, so we're just gonna do equations today. So one of the main things I wanna show you guys, let's jump to this box right here, all right, where it says property of equality for exponential functions. All right, and actually before we go into it, I think it's very intuitive. I think you guys can figure this out. So for example, if 3 to the x power is equal to 3 to the 5th power, then what do you think x is going to equal to, guys? Logically, what would x then equal to? Good, thank you, in the chat box. Yeah, type it in the chat. What do you guys think x will be equal to? Just using sheer logic. Good, yes. You guys are great. All right, so yeah, x then should be equal to 5. Okay, that makes sense, right? That this would then have to equal to this. All right, so this is actually a property in math. All right, this is called the property of equality for exponential functions. So to put this in a very general way, that means if some base to the exponent is equal to the same base, notice it has to be the same base to an exponent, then x must then equal to y. All right? Okay, so we're going to be using that property. Now, before we get into our main questions here, I do want to practice a skill that will be coming in handy. All right, and that's this warm up right here. Let's see if you guys can help me out with this warm up. It says rewrite the following terms as exponential expressions with the given bases. All right, with the given bases. So what that means is, for example, 64. If I want to write 64 as 4 base, what exponent would have to be on that 4 to equal to 64? Go ahead and put that in the chat. What exponent should I put up here for that to equal to 64? Good. Nice. Good. Waiting for a few more. Okay, good, good, good. Yeah, nice, guys. So yeah, that exponent would be 3. So if I wanted to write 64 as a based 4, I would put 4 to the 3rd would equal to 64. Okay. Try this one. This one's a little harder. 1 over 9 is equal to 3 to what exponent? Ooh, this one's tougher. Who's got this one? Good, yes. Yes, people with the question marks. Good. Yes. Yes, person with the question mark. No, not -1. That would be 1/3, so you're close. Good, yes, yes. Nice. Okay, good job, guys. Yeah, this would be to the -2. All right, -2, because the negative is what flips the fraction, and 3 to the 3 to the 2nd power is what gets you the 9. All right, good. Okay, now let's try with number 3. All right, throwing in a exponent of x here. Let's see if you guys can figure this one out. So we got 8 to the x will be equal to 2 to what power? Ooh, close. Good, yes. I got a right answer. Good, yes. Person with the question mark, that is correct. Ooh, close. Keep in mind, you're not doing 2 times the number. It's 2 to the power of that. All right, close. A lot of you guys are getting like either the whole thing or like part of it. Okay, so let me show you what it is. Oh, good. Yes. Okay. Oh, I'm getting more right answers. Good. Yes. Good. Person that wrote 4x before, you fixed it. Good job. All right. Final answer. Lots of you got it. Was 3x. Good. All right. And if you want to see that even more clearly, you can see it almost as 2 to the third to the x power. And that's what gets you that 8 to the x power. Good job, guys. Nice. Okay. I think this is going to be a good lesson for you guys. Okay. So, number 1, let's kind of put all that together and solve the equation. All right. So, for number 1, I want to figure out what x has to be, right? Now, again, if you look at our property, we can only set those exponents equal each other if the bases are the same. So if you look at number 1, our base right here, 2 and 8, are not the same. So that's why we need to change one or both of those bases to get them to be the same. So we're going to use the skill we'd used in the warm-up, and let's change 8 into 2 to some exponent. All right. And I think you guys know that this should be 2 to the third to replace the 8. And then we have the 2x plus 3 on the outside. Everybody cool with that? Anybody not okay? Let me know in the chat. All right, because there's an essential step right here. Everyone's good? Okay, all right. So from here, now we have 2 to the x minus 1. Now, when you have an exponent to an exponent, remember you multiply. All right, we multiply. So then this is going to be 2. I'm going to distribute that 3 to the 6x plus 9. All right. And now that I have the same base, I can just focus on the exponents. X minus 1 is equal to 6x plus 9. Okay, subtract the x, and that gets me 5x. Subtract the 9, and that gets me negative 10. Divide the 5, and I get x is equal to negative 2. All right, and that is my final answer. Okay, let me see if there's any questions on that. You can put in the chat or unmute yourself and just let me know. No? Okay, all right, let's try number 2. I'm gonna start calling people, so get ready. Here we go. All right, so number 2, let me see if Celine. All right, Celine, can you help me with number 2?
Yeah.
Okay. What do you think, Celine? What should we do first? What do you think?
You should change the 9 to 3 squared.
Good. All right, so let's get that 9 to be 3 squared. Okay. And then what about the 1 over 27?
27 to the power of negative 1.
Oh, okay. You're right. But remember, our goal is to get the same base. So I want this to be 3 to the power of something to get me 1 over 27. So 3 to the power
To the
of
power of 3.
3 to the power of 3 would get me 27. What would get me 1 over 27?
-3.
Good. There you go. All right. So that's what we have. Okay, good. Now that's the hardest step. So good job. So from now or from here, what do we do? What do I do with the -3 and the rest? What do I do with these two guys?
We would
Good.
multiply them together.
Good. So what do you get? 3 to the power of?
-3x minus 9.
Good. And then what about on the right-hand side? These two.
4x minus 2.
Good. And now what can I do?
You would remove the base and then subtract them together.
Good. All right. So let's solve. And what do we get? So do you want to subtract the 4x over, or do you want to add the 3x to the right-hand side? I'll leave that up to you.
Oh, I added 9 on both sides first.
Ooh, okay. Perfect. All
And
right.
then so -3x equals 4x plus 7.
Perfect.
And
Okay.
then you would minus both sides.
Good. All right. And what does that give
And then
us?
divide by,
Okay. And then, so x
to
is,
get x is equal to
oh, sorry, you cut off. X is equal to?
-1.
Perfect. Great job, Celine. Nicely done. All right. That's how it's done. Good job. All right. Any questions on that one? Okay. Let's do number 3 because this one looks little gnarly, right? Number 3. Okay. So let's see if you can help me out with this one. Mateo, can you help me out with this one? What do you think?
Um, I'm not sure how to make it the same base.
Okay, good. I'm glad that's what you're trying to do, though, because I was just about to ask you, what should we be aiming for? And that's exactly right. We want the same base, right? Okay. So if you look at it like, obviously it's going to be a fraction. The base is going to be a fraction. Okay. So the question is, what is like the nicest fraction we can make it? So if you look at these numbers, 8, right? What are like what typically would the base be for the 8?
2,
2. Okay. And then for the 27?
3,
3. Okay. So let's go ahead and let's try that. So this would be if I did 2/3, right? This would be 2/3 to the power of what to get me 8 over 27?
3.
Good. All right. So 2/3 to the power of 3. All right. Let me see if I can write that a little bit better. All right. So 2/3 to the power of 3, and that whole thing to the 2x minus 3. Okay. Now I want 9 over 4 to also have a base of 2/3. So
So would it be to the power of -2?
yes, good job. All right. The negative will flip it, and the square would give it the 9 over 4. Nice. Okay. So that's how you do it when it's like more complicated. Kind of like set one base and then figure out the exponent for the next. Okay. So Mateo, what do we do from here?
Multiply the exponents.
Good. All right. So let's go and multiply the exponents. What do we get?
6x minus 9 and -6x minus 4.
Nice. All right. -6x minus 4. Okay. From there, keep going.
Um, Add 6x. Oh, well, yeah, okay.
Yeah.
Add
Sorry.
6x on one side
Uh huh.
um, and add 9 on the other side.
All right, so that's 12x, add 9, add 9. All right, and that's 5. Okay, so final answer?
X equals 5 over 12.
Perfect. Good job. Way to figure that out. Okay, great job, guys. Okay, let me just kind of zoom out in case you need any of those uh, previous ones, and let me see if there's any questions. All right, if there are no questions at this point, you know what? Let's practice. So I want you guys to try, let's have you try number 5, okay? Try number 5 on your own. Once you have your answer, type it in the chat, and then we'll see what you guys have. All right, go for it. Number 5, try it. All right, guys, let me go ahead and show you number 5 if you are ready. So number 5, here's the answer and work. Ta-da. All right, so number 5, the answer was 14 over 5. So great job. Those of you guys who got it, really, really good job. Those of you guys who got number 6, kudos on that. All right, so number 6, the answer was x is equal to 0. Okay, I'm not going to show this one unless you really need me to, because I want you guys to try to wrestle with it. Okay, so x is 0 is the correct answer though. All right, let's go ahead. Great job. Let's flip to the back side and try out these word problems. Okay, so number 7, read this out for me, please. Brendan, please read this out for us.
Number 7.
Yeah, number 7, Jessica starts.
Jessica starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. How many bacteria cells can be expected in the sample after 12 hours?
Thank you. All right. So I actually have this kind of written out. So really the question is just this part. Like that's all you would be given on like a quiz. But I have these step by step for you to kind of walk you through the process. Okay. All right. So step 1, what you want to do is write an exponential function to model the number of cells after X hours. So if you guys remember the exponential function from yesterday, let me actually call in somebody, see if you remember. What was that equation, that formula that you got yesterday? Michael, Y. Do you remember what it was?
Yeah, it's y equals ab to the power of x.
Good, nicely done. All right, so y is equal to a parentheses b to the power of x. Perfect. All right, so the next part is, well, what does each part of the function mean? All right, because well, that's pretty important, right? Knowing the formula is good, but you need to know what each part means. So A, what did the A mean? Celine, what did the A mean?
I think A referred to the original amount.
Good, yeah, the original amount. I like that better, actually. I'm going to do that instead of initial. Original amount. Nice. Beautiful. And then B, what was B? Gloria, what was the B in this formula?
Was it the
It starts with an R, if that helps.
R? Sorry, I forgot.
It's okay. Yeah. Can anybody help? You can put it in the chat too if you want.
Wasn't it ratio?
Yeah. Or yeah, rate or ratio. Nice. Good. I think I put rate yesterday. Nice. Okay. So yeah, that's like the rate of growth or rate of decay. All right. So I'm just going to put rate. All right. And then I didn't write this yesterday, but X is the amount of time. All right. So X is time. Okay. And then Y is the final amount. Okay. So Y is final amount. Cool. All right. Next part, what information can we fill in? All right, so based off of what they give us here, for the formula, they give us the initial amount, right, of 7,500 bacteria cells. So we can actually fill out the A to be 7,500. Okay, we don't know what the rate is, and we want to leave X and Y open so that we can plug in whatever X to get Y. All right, so this is our formula so far for this bacteria, okay? All right, next step. Solve the exponential function for the missing part, and what does this represent? All right, so we don't know what B is. So B is our missing part in this case. All right, we don't know what B is. So in order to figure out what B is, we can plug in one instance, all right, which they give us to figure out what the rate is. So all we know is after 4 hours, there was 23,000 cells. Knowing that's going to help us figure out the rate, okay? So I'm going to plug in 23,000. I'm going to plug in the initial 7,500. We don't know the rate, but we know this was after 4 hours. Okay, so that's going to be enough for me to solve for B. All right, so let's do that. So let's solve for B. I'm going to plug or divide 7,500. And yes, you can use calculators for this. Definitely. All right, so I get 3.06 repeating. All right, is equal to B to the fourth. And then I'm going to take both sides. You can either fourth root both sides, or since you guys know the rational exponents, I can take both sides to the 1/4. Either way, your calculator will give you the same answer. All right. I think it's easier on the calculator to do the exponent, so I'm going to do to the power of 1/4. And that gets me 1.323. All right. So that formula now is y is equal to 7,500 times 1.323 to the x. All right, let me take a pause, see if there's any questions up to this point. Did I lose anybody? Okay, all right then. This, and what does this represent? This represents the rate of growth. Now, does anybody know why I know it's growth as opposed to decay? Like, how do I know it's growth? There's different ways to know that. Oh, good. Yeah. That's what I was thinking. Yeah, B is more than 1. Good. So yeah, when B is more than 1, it's going to be increasing. When it's between 0 and 1, that means it's decay. So good. All right. And now we can answer the final question. Use the exponential function that we made to solve the original problem. All right, so the problem is how many bacteria cells can be expected after 12 hours? Okay, so after 12 hours, I can just now plug in and see how much bacteria is left once I plug in 12 for x. So plug that in times 7,500, and I get a decently large number. All right. Now you might, get a slightly different answer depending on where you round. So that's okay. If you're following along and you're like, wait, I got like 216 or something, it might just be we rounded differently. And that's okay. That's why I have you guys show work, so that if you have a slightly different answer, But your work is correct. You're all good. Okay. All right. And don't forget the units. This is bacteria cells. So I'm just going to write cells. And that is your final answer. Okay. All right. Any questions? Any concerns? Let me zoom out so you can see the whole problem. If you do have a question you're typing, keep going. If you are good to move on, though, please move on to number 8. All right. If you have a question, keep typing it in.
Sorry, I got kicked.
It's okay. It's okay. All right. Actually, Liam, can you read this next one out for us?
Yeah, sure. Okay. A mug of hot chocolate is it's at 90.
90 degrees Celsius.
Okay. At 1 p.m. At 1:15 p.m., the temperature is dropped to 45 degrees Celsius. Write an exponential equation to model the temperature of the hot chocolate. Y in degrees Celsius. Write the equation in terms of X, the number of minutes after 1 p.m., and then find the temperature of the hot chocolate at 2 p.m. Is this prediction reasonable?
All right. Thank you. All right. So I'm going to actually write this all out so it's a little easier to understand. So Y is going to be the temperature of the hot chocolate. All right. That's what they told us right here. And then X is going to be the number of minutes after 1 p.m. Okay. All right. Which means that this 90 degrees Celsius is our initial temp, right? Because it's at 1 p.m. So that's going to be my A, right? Will be my 90 degrees Celsius. That's the initial temperature. Okay. We don't know what B is. All right. That's what we need to find. But they do give us an example. So that's going to help us find B. Okay. All right. So before we get too much into it, let's start, working on it. Let's go to Yanni. All right, Yanni, help us set this up. What is our initial setup here? Y is equal to what?
90 bx b to the power of x.
Good. All right. And Yanni, how are we going to find out what B is? Like, what should we plug in to X? And what should we plug into Y?
X, wait, I'm not sure.
Okay, that's okay. So do you see this part I'm circling right now?
Yeah.
All right, yeah. All right, let me highlight it. There we go. So we're going to use this. Okay. Now, that is like a specific case so that we can use to solve for B. So let's start with the X. If they're saying it's at 1:15, what is X? How many minutes after 1 p.m. is that?
15.
Yeah, 15, exactly. All right, so let's plug in 15. And then what is Y?
45.
There you go. All right, do you see how that works?
Yeah.
So now you only have one variable, right? So what do I do to solve? What should I do first?
Divide by 90 both sides.
Nice. All right, divide 90 both sides. That gets me 0.5. Okay. And then now what do I do? To the power of what? We'll get rid of that 15.
Something 3.
All right, look at the one I did up here. So that b to the 4th, what did I take it to the power of?
1/3, 2.
Oh, do you see that b to the 4th? I took it to the power of what to get rid of that 4? exponent on the b.
Times 1/4.
Yeah, times 1/4. So use that, and then to get rid of the 15,
Or times 1/15.
there you go. All right, so 1/15. Okay? All right, so then that leaves me with b to the first power, which is just b. And then this is 0.95. All right. So far, so good. All right, I got a question in the chat. Why is 45 substituted for y when 90 takes the place of a? Great question. So the reason why is because 90 is the initial temperature, right? That's why it's a. It's the initial temperature. 45 degrees represents how much the temperature or what the temperature is after 15 minutes. So that's why it's 45 for y after 15 minutes. Does that answer that question? Cool. All right. Good job, Yanni. Okay, next, let's go to finding the temperature at 2 p.m. All right, because of time, I'm going to go ahead and take over. So to find the temperature at 2 p.m., all right, I have my equation. My B is 0.95. At 2 p.m., I need to set x to be number of minutes after 1 p.m. So that would be equal to 60 minutes after 1 p.m. would be 2 p.m. All right. And once you plug that all into your calculator, you should get 4.146. And we're talking about degrees Celsius. So I'll just do 4.15 degrees Celsius. All right. So is this prediction reasonable? What do you guys think? Is that prediction reasonable? You can put that in the chat. Good. Yeah, that is absolutely not reasonable. That's pretty darn cold. It's like your hot chocolate's not going to freeze if you leave it out, right? It's just going to regulate to whatever like room temperature you have. So I would probably say no. It shouldn't go below room temp. All right. Good job, guys.